Edexcel A-Level Maths, Pure Paper 1, June 2022, question 11. Figure 4 shows a sketch of part of the curve C1 with equation y equals 2x cubed plus 10 for x larger than 0, and part of the curve C2 with equation y equals 42x minus 15x squared minus 7, again x larger than 0. For part A, we need to verify that the curves intersect at x equals a half. So all we need to do with this one is to take our x equals a half and substitute into the two equations and see what y value we get out. So for the first equation, y is going to equal 2 times a half cubed plus 10, which is equal to 41 over 4. For the second equation, we're again going to substitute that half in. So y equals 42 times a half minus 15 times a half squared minus 7, which equals 41 over 4 again. So y is the same for both equations, therefore the curves intersect at x equals a half. It's important just to put those last two bits in there just to state exactly what it is that we've verified and why we've managed to verify that. The curves intersect again at the point P. For part B, we need to use algebra and show all stages of our working to find the exact x-coordinate of P. If we've got two lines meeting each other, then we know that we need to set them equal to each other. So we're going to have the 2x cubed plus 10 from the first equation equal to the 42x minus 15x squared minus 7 from the second equation. Rearranging this, we get that 2x cubed plus 15x squared minus 42x plus 17 is equal to 0. We need to try and solve this cubic equation. But we've already been given an answer. We know that x equals a half must solve this cubic because that's where the curves intersect. So if that's the solution, then we know that 2x minus 1 is a factor. We've picked 2x minus 1 because if we put a half into that, we would get a 0 out of there. 2 times a half minus 1 is equal to 0. Because we know this is a factor, we can divide our cubic by this 2x minus 1 to get a quadratic, which will be a lot easier to then solve. So here's our division. We're going to put the cubic underneath. We're going to put our factor 2x minus 1 on the left, and we're going to do some long division to get our quadratic out of this. We're going to start by dividing the 2x cubed by the 2x in the factor. Well, that's going to go in x squared times. That goes on top. Underneath, we do x squared times by our divisor, the 2x minus 1. So 2x minus 1 times by x squared gives us 2x cubed minus x squared, which we then take away from the first row. So the x cubes cancel. 15x squared minus x squared is 16x squared. And we bring down the minus 42x and the 17. We then repeat ourselves. So how many times does our 2x from the divisor go into 16x squared? That's going to be 8x. Again, multiply the 2x minus 1 by this to give 16x squared minus 8x, and take away and see what we've got left. So this x squareds cancel, minus 42x minus 8x is minus 34x, and we've brought down the 17. How many times does 2x minus 1 go into this? That's going to be minus 17, and let's just double check. If we multiply the 2x minus 1 by the minus 17, we get minus 34x plus 17, so there's no remainder. Everything's divided perfectly. So our answer is x squared plus 8x minus 17. Now we've done the long division, we've found that our original cubic is equal to 2x minus 1 times by x squared plus 8x minus 17. So the 2x minus 1 part of this gives us the x equal a half that we've already got. The answer that we're looking for point P must come from the x squared plus 8x minus 17. So let's solve that. We set it equal to 0. You can solve this any way you like, putting it into the calculator, whichever, is up to you. I'm going to complete the square. So this is equal to x plus 4 all squared. So I've got the 4 by halving the 8 there. Minus that 4 squared, so 16. And then we've still got the minus 17 on the end. And this is equal to 0. Adding the 16 and 17 to both sides gives us x plus 4 all squared equals 33. So x plus 4 must equal plus or minus the square root of 33. So x is equal to minus 4 plus or minus root 33. But this is two answers, and we just want one. Looking back to the question, we're told that x is larger than 0, but minus 4 minus root 33 must be smaller than 0 because that's taking away two numbers. So that's not the answer we want. We just want the positive one. So our answer is x equals minus 4 plus root 33. Remembering to keep this as an exact coordinate as the question has asked for. If you've enjoyed this video, remember to subscribe to the Doing Maths channel to keep up to date with all the latest releases.